Beautiful. So Jeff, Lindsay here, guys, thanks for coming out. Also, at least we forget, or lest we forget, Rackspace as our venue sponsor. So thank you to them. Yeah, very good. So with that, Jeff, Lindsay, Glider Labs. By the way, what does Glider Labs do?
Well, we were actually one of the first consulting companies to help people run Docker in production. I helped create Docker as an outside collaborator with Solomon, sort of a skunkworks team. And so I had a lot of ideas. I did a bunch of work and open source stuff, some of the top things like Registrator and Logspout. And if you've used Alpine, that's maintained by Glider Labs. If you haven't used Alpine, you really should for all your containers. And we were doing consulting and trying to push, this idea of what how these systems should be built even before Kubernetes and such, and trying to take a bottom-up approach. And then I realized that was consulting is not very fun, so I don't do that anymore. But we build open source stuff now. How much time do we have, by the way? Because, I could show you some cool stuff that nobody's seen before after the talk, if you guys are interested.
So just, Jeff, really quick, is that how we measure time now, by when Kubernetes came onto the scene? Or?
I have a lot of ways to measure time. I'll just get to this talk. So cluster managers, we're all familiar with cluster managers are, the kind of class of tool that they are, right? Orchestrators, do people call them orchestrators? I hate that word, we'll get to that. So I actually, for my own purposes, actually I'll explain why, but I'd like to poll you guys really quick. Although I can only poll people that work at companies under 1,000 people and know how many servers they run. How many people don't know how many servers they run or work at a place with over 1,000? Okay. So the rest of you, how many of you run more than 1,000 servers? None. Okay. More than 100? Is that a maybe? Absolutely. Did you raise your hand at 1,000? No. Okay. And yeah. Okay. More than 50. You can raise your hand again. More than 20. Okay. 10 or less. There's a very oddly even distribution across all of those. I should have explained it. It was in whatever you manage, like if it's a VM or if it's a server. If it's on hardware thing, real, non-virtual. That's some data points, because it's actually really hard to find this data of how many servers people have used in production. Okay, so real stuff. So a little bit of history. This is actually really cool. I'm not starting, you're like, 1995. I was 10 in 1995, but my dad had just started an ISP in 1994. And so that was kind of cool. The reason why I'm starting in 1995 is because that's when things got serious, because before that, you couldn't actually do commerce. We didn't have a workable SSL 2.0. The public SSL came out in 95. It's kind of weird. It seems late, even though they were working on it since 93. So it was at that point that it actually mattered if your servers went down, right? And so downtime meant lost revenue in a lot of cases. And back then, people would scale vertically, bigger server, more memory. More CPU. Actually, some people, my dad actually at a liquidation sale found some Cray supercomputers And so he advertised, host your website on a supercomputer. And you would often have basic redundancy, so like two machines. Very much servers as pets, right? You don't have very many, so just take care of them and keep them orderly. 98, Google comes out. A bunch of stuff leading up to 2005. So there's sort of three phases here. But I call this a transitional phase. Around 2005 is where we got sort of the dawn of Web 2.0. We got all kinds of new stuff, wikis and social. You guys remember Flickr? Flickr's still around, right? Yeah. So, one of the lead engineers for Flickr is now, I believe, CTO for Slack. He wrote a book in 2005 called Building Scalable Websites. Have any of you read it? It's such an excellent book. It's sort of the precursor to all DevOps. And then also EC2 finally came, sort of invented cloud computing. And that was really interesting. And then also because Google had been around for a while, they started sharing some of their secrets. Right, MapReduce was one of the big things that they were talking about, and also that they were using commodity hardware and just cheap, scaling horizontally, totally, different than what everybody else was doing. And so then, a couple of years later, DevOps sort of forms, and you have Chef and Puppet. Although the configuration management thing really, in my mind, started in '93 with CF Engine. Anybody know CF Engine? Yeah. The idea of treating servers as cattle, and that was bleeding edge in 2005. Now people are still kind of catching up to that. Also, App Engine came out after EC2. And it's kind of funny because Google couldn't have really done an EC2 because their infrastructure it was already designed. They already made Borg, right? So in 2000, and that was sort of their secret sauce for the longest time. And so they didn't really have the same, infrastructure that they could do. But they could do App Engine, but it was way too ahead of its time. I mean, I think it was quite ahead of its time. And with that, they invented platform services, PaaS stuff, which Heroku eventually, all these other things. And what's interesting is, in my mind, that's actually where there's this whole circular thing, because the whole cluster manager thing, which is sort of, and even though we say cluster, we've been saying clusters forever, but what we mean by clusters is like a set of servers that we mostly sort of maintain individually with software, but we still kind of think of them individually. The whole point of a cluster manager is sort of, you don't really think about them at all. When you're running stuff on them, you kind of treat it as the aggregate. So the aggregate actually exists. You just say, here, run some stuff. And I know we've had cluster managers, specialized cluster managers and stuff like that for a long time, but I guess what we're getting at here is sort of the general cluster manager, right? And this kind of part of the big, a lot of people were doing container stuff when Docker came out, but Docker obviously, was sort of this big tipping point, and at least hinted at this idea that got a lot of other people thinking, and Kubernetes was also already kind of going in that direction. And then came out, or I think 2015, right? Kubernetes 2015, at least sort of announced, right? Yeah, I think, yeah. There's some other interesting stuff that I won't get into. So there's Docker, and we have all of this excitement, and this is just ridiculous. And some of this stuff doesn't even make sense, but people like making these kinds of slides. They're totally useless, I think, but people make them anyway. So part of this sort of Cambrian explosion was because of the success of Docker. And then, a lot of people sort of felt like, I mean, it's sort of hinting at this cluster manager thing, but all we had was, Docker engine. So people are sort of like, well, what about the rest? Docker is not enough. In fact, somebody gave a talk called Docker is not enough. But that was the point. It was meant to be a building block, and that's really how I think good software, that's how I think about software. You should build building blocks to build the software that you want to build. And I was involved in Docker because I was interested in disaggregating the platform service. And Docker was previously .cloud. They were a Heroku alternative also with this past background. So this phrase disaggregation, I'm actually quite a big fan of. What does it mean? Well, I mean, it might make you think of like microservices, could make disaggregating your monolith into microservices. It's sort of a generalized thing. If any of you have seen this is where I saw this really used. But at Facebook's people that are sort of reinventing and their the foundation or whatever, sort of reinventing the data center. And a lot of the hardware in there are talking about breaking down a lot of these, both switches and also the server systems themselves into core components so that they can kind of re-aggregate them in different ways and optimize them. The point being that you can advance the individual system components separate from the system, which is really important. But I think this is actually really important in software, maybe more important because software is where complexity can really skyrocket. How many of you have worked with Kubernetes or Mesos? So in general, even regardless of cluster managers in general, I'm not all about cluster managers, I'm not about Docker, but they're sort of a means to an end for me and my goals. And I have a totally different perspective on everything than almost everybody else in this industry. But I think we need better building blocks. We need to take systems and disaggregate them and get good building blocks and then reaggregate if we must. But this way we can do a lot more with less. But there's a big problem, which is, sorry, I'm going to be clearing my throat. I'll try and minimize that. Building blocks are great, but we're not incentivized to actually make them. Especially a lot of the vendors in this space, they're VC-funded companies. They need to make a lot of money, so they make things that are geared towards enterprise, large organizations. So they build solutions, and building blocks are not solutions. So they have no incentive to actually build building blocks. Almost nobody does, really, except for maybe just open source developers. But if you're an open source developer working at a company that's VC-backed, your priorities are, it's going to be weird. And this is kind of a nice ideal, right? This is sort of how customers think, oh, I have this problem, I'm going to find the right solution that fits right in. And that's how it works, right? I mean, usually, though, the reality is we have a solution that looks like this. Yeah, and, all I really need is, like, this bottle opener, maybe the corkscrew, a knife, one of the many knives, why not? And then that thing, because it looks cool. But I would also, I was just thinking about this, I'd really like fingernail clippers. And I can't seem to, it might have it, I just don't see it. So maybe go tell somebody to go do some research and find something that has toenail clippers or fingernail clippers. And they do research and they come back with this. I was like, where's the toe? And then, oh, it's right there, if you can see it. So now we have everything that we need. I guess we'll just, make it work. And so I don't know about you guys, but this is kind of how I feel. And even Docker has done this. It used to be a really simple primitive, but now because everybody's sort of racing for, cluster management, higher abstractions and all this, solving the problem, the solution that they can sell. Even Docker is one of these now. And I call this the systems software mess. So anyway, it turns out a general purpose cluster manager is hard. It's sort of a distributed system manager. I mean, I guess you can look at it that way. And one of the difficulties in general with software is that, even with any inherent complexity, we tend to make it more complicated than we need to, because it takes a long time to understand the simplest way to do something. It turns out distributed systems are inherently quite complex, and I can prove this. Here are two open source passes. Have you guys heard of Flynn or Doku? So Doku I wrote, and Flynn I co-architected originally. And these numbers aren't right, but the proportions are right. Can any of you guess what the difference is between these two projects? Ah, yes. The one that's distributed has a lot more code. And actually, because Doku runs on a single host, it's just like, don't worry about multiple. It turns out that's a huge thing. Like, people run it in production. I was surprised. And they make it work, partly because it's so simple and extensible. This is Doku originally. 65 lines of bash. And it was a Heroku clone. And it was based on components, some of which I made. Most of the heavy lifting done by Docker. Is also very extensible, a plugin system. And so, I literally threw this together for a talk like this one as a demo, and then I was like, I open sourced it, and then it got really popular. But this is only possible because I was like, what component, I'm trying I wanted to be able to throw together a platform service. I think that's generally something to desire. So disaggregation is important to me. If you guys, I think a couple years ago, have you seen this before? My friend Gabriel came up with this sort of OSI-ish stack of pancakes. And, it was a good kind of attempt of trying to categorize. I hate ontologies, but it's just there's so many. That's pretty good. We don't care about anything below the container engine now, right? Okay. The one thing that that was really useful value add to this was his idea that platform service is really just a really thin workflow layer over a cluster manager. But we're not talking about that. So this is really annoying to me because these are sort of like, well, which, I don't know. Is anybody else frustrated by this distinction? Okay. Because, and part of it is because Mesos was backwards in they had this weird inverted model and all this stuff. But it's really, this scheduling is sort of, depending on how you look at it, part of orchestration. Like I said, I hate orchestration. What does it mean? Workflow is a form of orchestration. How is that different? So I really like just saying cluster manager. So I fixed this. It's better now. Okay, so I've changed the name of this talk. It's now Building Blocks of a Cluster Manager, and now I'll actually get to some useful stuff. My goal here is, and because of time, I can't go into details. We can talk about details afterwards if you're interested. The idea is just to map out some high-level ideas, because a lot of these things are reproducible independently, and a lot of what we did with our clients was building low-tech versions of all of this as stopgaps, since there was no good solution, no ideal cluster manager at the time. I still don't think there's, Kubernetes is pretty close, but it's also very popular, and open source is additive, so it's only going to get more complex from here. Okay, prerequisites. We already have these. Container engine. I was going to go on a whole rant on this because I feel like everybody has a broken mental model of Docker. But I won't. Distributed coordination, we're all familiar with this by now, like etcd, console, Zookeeper, Doozer. Yes? Okay. So we have those. Okay, what do we need? So we've got a bunch of hosts, right? And what we're trying to do is turn these hosts into, conceptually, like one thing that you can give work to. And then you don't really care what hosts it runs on. So the first step is kind of what I call like inventorying hosts, like what host do you have, but also what information do you have about them. There's like static properties, things about them, what specs, how much memory they have, disk space, network, metadata like tags. You might have interesting ways you want to categorize this, which might be useful in the way you want to schedule jobs. But also, what a lot of people think is most important, resource utilization, which is something you can't really get from the outside, because a lot of this you get for free with EC2 or Rackspace, I suppose. So a way to basically get all that stuff into one place so that something can make a decision about where to run stuff. And this doesn't really exist as a standalone tool, like maybe OS Query. I just don't like that SQL model. I've almost built this so many times. It exists in other systems, like if you use Chef, Ohi, and Knife, you can sort of query systems based on the properties. Like if there's just like a standalone, you can run Ohi, but then you need some way to like get that. But if you were to just feed that into like a parallel SSH tool, that's a lot, regardless of cluster management nonsense, like that's very powerful, right? Once we have all that state in one place, and although there are certain ways you can design a cluster manager where you don't centralize this, I think this is the way it's gonna be done anyway. Put it all in one place so that you now have the state of the cluster. And so now the cluster is an actual thing. You have a data representation of it and everything about it. So that's step one, just inventory your hosts. And I think there should be a component for this, and there isn't. The other one is kind of glossed over in all this, is like the unit of compute, right? Or a description of compute or work. Docker really helped because they sort of like, Docker, it's not about containers. It's about a unit of software, right? And a runtime for it that you have an API for. So Docker has really influenced the definition of this. Almost every cluster manager that uses Docker or is pluggable has, very similar like Docker run parameters in it. Though sometimes you need to run multiple containers, so most of these will have multiple definitions of things to run. Docker Compose, even though it was sort of this sort of silly YAML file format, does kind of represent the modern format for a unit of compute. Kubernetes pods are the same thing, and they're all roughly the same thing, just describing what you're going to run. But if you think about it, we don't really have like a standard for that. Maybe systemd units or something like that. And so traditionally these are called jobs. There's a lot of ambiguous naming in these. Sometimes they're called tasks, but sometimes jobs are made up of tasks. Don't worry about that. This is the real heart of it, though. Once you have those two things, your aggregate thing and your unit of work, you'd want to just like put them in the cluster, right? But where do you put them? And so that's placement or scheduling. And something needs to decide where stuff goes based on, well, it seems like everybody that works on these things thinks that resource utilization is the most important thing, but I think that's an optimization. There's a lot of other things that can be really important in your scheduling strategy, like, running in multiple regions, and stuff that actually is required to enforce your SLA. And every organization is different, even though there's a lot of best practices and stuff like that. But I find it quite annoying and maybe a little arrogant that a lot of these schedulers are not making our strategies more programmable. At least they're pluggable now. Like some Swarm and Kubernetes have pluggable strategies. And that's it. That's all. Which is kind of a lie, but it's also kind of true. You might think, well, what if those jobs fail, and how do they communicate, and what about logging and security and metrics? Well, I will get to those. Actually, everything I just described is pretty much all there was in the original Swarm, and obviously it wasn't enough. But they made some other mistakes. One of them was their API. They had this sort of assumption that all jobs are equal. You can just use the Docker API to run containers because everything runs in containers, right? And that might have been one of the biggest flaws, just ignoring the fact that there are fundamentally two important job types, ignoring specialized cluster managers and stuff. There's services or long-running processes, which is, a lot of people are like, well, that's all there is. But there's also these other things that you often forget about, which people call them tasks, but that's ambiguous with command or ambiguous with job. In papers, they're referred to as batch jobs. But they're basically commands, like you run on the command line, something that starts, runs, and stops. And sometimes these are administrative tasks, maybe stuff you run from cron, often overlooked. In fact, the new version of SwarmKit, has no support for this. It only has services. They learned that they needed services, but they forgot that you also have commands. And this is important because these two things actually define the rest of what you need in a cluster manager. A cluster manager, a service is going to need what I'll just call service supervision, sort of like process supervision, which is probably the most interesting part of it, and replication, having X number of them running and stuff. There's also a couple of other things, but the command jobs don't have any of that. You don't really have replication of a command. If it's done, it's done. You don't want to restart it. But it also has its own properties, like maybe it's a synchronous job, you're submitting it, and you want to interact with it. Maybe you need a pseudo-terminal. And these are all things that often are ignored. Anyway, these are the two types of jobs. And if you read most papers on schedulers, they'll talk about these two things, because they're also important for scheduling and efficient for efficiently utilizing maximum resources. So a little bit on service supervision. And that's a state diagram for, I think, some sort of process supervisor. It's a little bit more complicated than that, because you could think, well, in Docker, you can just say restart the container when it's done. But if the whole host goes down, it's something else has to restart it. And so in Kubernetes, this is called a replica controller, which I think is a terrible name. But it's because it also ensures the X number of replicas are running. And it's based on this idea of ideal state. You heard people talk about ideal state. It's very important. It's also, not that new. In fact, all configuration management systems are based on ideal state. State-seeking systems. In fact, there's a whole field on this, cybernetics. It's how your thermostat works. And if autoscale groups was not specific to hosts, you could use it for service supervision, because it's basically that. So one way, Swarm, for example, builds service supervision into the manager. Kubernetes is the closest to come to this, which is, well, you don't really need to make it special. You can just run a pair of service supervisors on your cluster as a long-running process. They will monitor each other If one goes down, it'll schedule another one. And then using our leader election, using our distributed coordination, they're able to decide which one of them is going to watch all of the other services. And so then it's not even built into the cluster manager. And so that kind of hints at how I think of most other requirements of a cluster manager. Service discovery is one I've spent a lot of time with and have found very effective ways to give you magic service discovery, which more or less means you don't need an SDN in most cases. But it doesn't, most of these cluster managers make it hard to use your own service discovery. Health checks is very complicated because they're used at so many levels. They're used by service discovery to do service discovery correctly. You want health checks. And your service supervisor should probably also have have real health checks, not just is the service running. Logging and metrics, these are things that I feel are quite orthogonal to Docker in the first place, but having some good shims in there, like Logspout. Anybody use Logspout? Okay, good. It's terrible. Networking is a big part of a lot of cluster managers. SDN in general is very popular. And I want to have a whole rant on this, but I'm going to ignore it. Security policies. I mean, this is not an exhaustive list, but if we want to talk about these after, we can. My point is that you should be able to throw together a cluster manager. But I also believe you should be able to do that about anything. In theory, there are a lot of implementation details that I skipped over, but with this talk, you now have a map to actually build a low-tech cluster manager for yourself, especially at the scale that most of you guys are running. There is a strange obsession with scale, and it's part of it is because does it scale? And selling to enterprises that have scaling problems or whatever. But the majority of people are in a long tail that don't have. I'm trying to remember the statistics, I should have written it down. A very surprising, it makes sense to some people, to my friends that are they work at Facebook and Google, they're like, no, that's not the case. But most people don't run that many servers. And that is to say, and some people argue that is a reason why they don't need cluster managers. I think everybody deserves a good cluster manager. But none of them are designed to work in the small, which is really important because that's how you get started. A lot of cluster managers, because of their dependency on these console and stuff like this, they require a minimum of, realistically, a minimum of 5 hosts, which is, not whatever, 5 hosts. But it's a lot. You're playing with it and all this stuff. Because 5 hosts, you basically need 3 stable nodes minimum for just your CP store. They need to be stable nodes. People for some reason think you can just start and stop those things willy-nilly, and that's not very practical. So you need them on stable nodes, which is complete opposite of your app nodes, which are stateless and are going to come and go. And you need redundancy, so that's 5 total. That's actually a big deal for some people. So when was this? I don't know when this was, recently. But what do we have? Kubernetes is in the lead, which is good. I like what they're doing. Docker Swarm, and then ECS. And ECS is funny. I want to close on ECS because it's weird. It's Amazon specific, although so many people use EC2. It actually seemed like a joke when I first, when it came out, and I don't remember how much it changed, but I looked at it and I'm like, what does it do? Oh, it's an API for running your containers on hosts. And I was like, well, we're already doing that with our low-tech stuff, and it works pretty well. And then I think in the process of like all of this, I realized it's actually one of the closest minimal cluster managers, right? All it does is you run an agent on a host, could be one host. And they're cheating because it's software as a service. But I feel like that's totally acceptable, again, for the majority of people. It's just unfortunate that it's EC2 specific. So you run an agent, and now with that and its existing EC2 data, it has that host inventory, it has the state of the cluster, and then it gives you an API that you don't have to worry about keeping up, that you give it your unit of computation, your job. And they have a couple of ways you can use it. One is give it some work, and it'll take care of running it. It doesn't matter, to you where it runs, so it'll just run it where there are resources. The other is, I believe they do support commands style stuff, so you can just like say, run this. I'm not sure how it works with it. I haven't used it, but what if you want to attach to it? It's probably a little bit more involved. And then the other thing that they do, which is kind of clever, is they give you an endpoint to run a job that also lets you specify what host to run it on. And when I first saw that, I was like, well, isn't that the whole point of a cluster manager? And then I realized, well, that makes it really easy for you to make your own scheduling decisions. They give you that host inventory, the state of the cluster. You can basically wrap that to implement any of those custom scheduling strategies, which is actually really nice. I would have preferred it to be more inverted so it gives you a webhook or some kind of callback to make that decision, but because now you have to wrap it. But ECS is I like it quite a bit. What else? So I guess actually I'm just going to go to questions, unless you guys want to see something completely unrelated. Maybe after questions, I don't know. Yeah, I guess that's it. What do you guys want to talk about?
I have do you want to ask? I got a question for you. Going back to something you mentioned earlier about what you felt that everybody had, like kind of a broken mental model for, I believe it was Docker itself, or the engine, whichever aspect it was that you mentioned. Do you want to maybe touch on that? Okay.
I wish I made a slide for this, because to me, I think very visually, but and I was one of the first, I was sort of user number one and started evangelizing, and I think even before Docker did. And one of the first talks that I gave about Docker, which is funny because I was like, can you let me bring Solomon along? And so we gave a talk, and I had this big slide that was like, containerization is the next virtualization. I was like trying to start this idea. But I didn't mean it literally, and a lot of people are using that as their mental model. People say, oh, it's like a lightweight VM. It's that alone basically starts people on a path of like, okay, so it's a VM. So what init system am I going to use? What Linux distribution do I like? That sort of stuff. And and I think most people have learned otherwise pretty quickly, but there's still a lot of kind of remnants of that. And then there's also this semantic ambiguity with the whole concept of containers, and people have tried to explain it in a lot of ways, like, containers have been around, and so there's low-level containers, and Docker's high-level containers, or application containers. Whereas containers are about kind of security and isolation in a way. That's just a useful tool for what Docker is trying to achieve, which is, to me, this sort of unit of software, right? Normally when I'm just going to pretend, well, yeah, okay. When you think of a host, your mental model of a host, there's any server, right? There's sort of like two big things in how you use it. There's a file system. Unix, Linux philosophy, everything's on the file system, all over the place too. It's not like, and then you have the process tree, and so you have all these processes, most of which you don't care about. They're just processes that keep the system running, or help start it up or whatever, and you might a lot of the time run like one thing on a server, but you have to deal with all this other stuff, and what is the API for this? Well, there isn't really an API. You have a combination of SSH, shell, and arbitrary tools that you can install. And so, which is why, there's some, this history of all these shell scripts and all this for automation. And it just doesn't have, and then on top of that, you have this weird idea of like, what is a unit of software? Like, can you point at software, like a program? Like you can point at the process in the process tree, but that doesn't touch any of the other files that it depends on. It doesn't touch on, the configuration. It doesn't touch on any of the metadata about it, like for the package, right? And of course, every piece of software is going to have different kinds of packages, so you don't really have, like, there is no unified way to represent software. It's very weird. And Docker sort of gave you that. It gave you a way to, in a way that's compatible with how our systems already work, Linux file system stuff, we can just package it up into something that is a unit of software that has an API, that you can inspect it, that you can control it, that you can manage it in a over an HTTP API. You can get and plus the runtime. The runtime is incredibly important because Docker events are how you do all kinds of interesting things. Registrator and these tools that I've made to automate service discovery are based on when a container comes up, there is an event that a container has started. So go inspect it and get metadata off it to put it in the service discovery registry. So it's all just automatic, and that would not be possible if there wasn't this sort of standard primitive or this API that Docker had, or if you're using Rocket, you don't have, I know you can do, what is it? I'm not as savvy with that space, the Rocket way to do things, but I know there's a way to get a daemon. I just don't know, does that daemon have events? I know they would love it if it was just like system dbus, but nobody is going to, and dbus has sort of failed at doing an actual distributed dbus. So to me, what Docker does, Docker Engine specifically, is it turns a host from this archaic Linux POSIX thing into a very clear thing. I can just think of it as a box with a bunch of slots, and I have an API to easily manage those slots. And there's all these other subtle things in sort of like that are based on like coming from the world of platform services that I think a lot of people miss. But everybody seems to be figuring it out. Like making really, small containers is really important. I was very surprised. Am I answering your question? Yeah. Okay. I was very surprised that Docker themselves. I mean, Docker. All their official repositories were these, the official images in their repository for all the software. They were all based on these like huge base images, and I know some people don't care because like a 10-minute deployment process is faster than anything their organization has done before. But I want instantaneous because that feedback cycle is incredibly important for all creators, like it's just super important. And you do, if you have to like, push an image, build it, and it's got all this stuff to build, and then it's got to push it to maybe a separate registry, so it's going to transfer like minimum 500 megs or maybe a gig, and then that has to be then sent to all your hosts separately. It adds up. And then so I found Alpine, and I brought it to the Docker community, and I was like, this is really great. It's like BusyBox, but it's got tons of packages, so it's really easy to basically install anything in it. And they've since like hired the Alpine guy, and changed all their official images over to Alpine. So they finally get it. Like, it makes sense to have small containers. I don't know. There's all these little things, but does that make sense?
Anyone else have a question? Here we go. Oh, just let me get you on the mic here.
Can you compare and contrast Kubernetes and Docker Swarm?
Do you know if you mean Swarm Kit, Swarm mode, or the standalone old Swarm? Okay.
How about the newer one? Yeah.
The newer one?
Well, Swarm Kit. Swarm mode, whatever you want to call it.
Yeah. I've slowly compare them. Well, Docker Swarm is a lot easier to get started with, but it is not. It's Docker has a history of kind of doing like what a lot of these companies did for a while is like they produce demoware. You know, it makes for good demos, but then there's all these things that they don't realize in use because they don't actually use it. Docker, the new Swarm, and one of the biggest problems is it doesn't, although Kubernetes had this problem too, basically focusing on just services. And they both have some SDN stuff and it's different. Actually, I don't think I have a lot of practical, like the differences that matter that I can compare. I actually use the old Swarm a lot just because, you know, it does give you that sort of ECS style minimum API for like cluster management, and then you can build a bunch of stuff on top of it. But I've yet to, as soon as we ran into that problem of, well, we can't just run non-services with Swarm, we kind of gave up on Swarm. And Kubernetes, I've been following, and I was really excited to start using it, but it just hasn't become something I want to use. Much more than like Mesos. I won't go near Mesos. But at least Kubernetes is componentized enough. My problem with projects, because Flynn had this problem too. When we started Flynn, we were sort of idealistic, and we said, we're going to make a bunch of components so that you could throw together a platform service, distributed platform service. And they had separate repos and all this stuff. And I think it's important to actually make reusable components that are actually used for other things. Eventually, because they took some VC money, they sort of focused on the solution, the PaaS solution that they will sell, in which case creating those primitives is not that important anymore. So they put it all into one repo, and even if they're different like Go packages and stuff, the problem is if they're not actually used by other things, they're not like reusable primitives or building blocks. And Kubernetes has the same problem, but at least they're a lot closer than a lot of other systems. Like good engineers like make things modular, but they still don't necessarily have the time to actually popularize a piece or think really hard about how to make a piece something that works outside of the system that you're working on, because most of the time they don't care, because they just care about the system they're working on.
You're saying,
Sure.
you're talking about Swarm, new versus old. Can you define it? New is 1.12 and old is like 1.9.
I don't think I can. I believe they call the old Swarm standalone now, and it was a standalone agent that you would run with Docker, and there was and the new Swarm is called Swarm. It's called Swarm mode because they've now baked into Docker engine a library they call Swarm Kit, which is a library that you can use to make these kinds of systems. And there's good stuff in there. Docker has some good libraries. They're really good at making libraries for things. And so they have Swarm Kit as a library, and now it's just built into Docker, and that makes it sort of easier to use because it's like if you have Docker, you have swarm mode. I think that's the main distinction, is they call it swarm mode and swarm standalone. But it's incredibly misleading, the fact that they're totally different systems. And they say that they're not I forget their official, what they're saying about standalone, but they're more or less saying like, we're going to maintain this, but it's not going anywhere. But I'm sure that someday they'll sunset it or something. But swarm mode versus swarm standalone. How many of you are going to make your own cluster manager now? I make it sound easy, but it's actually a lot of work. What I really wanted to share was a lot of the low-tech stuff that we did with our clients with SSH, and like our first attempts. We had a client. One of our first clients was like, "We want to use Fleet because Fleet is new." And Fleet, do you guys know Fleet? Like, it's not really talked about anymore because they've sort of, it was originally, the idea was a distributed init system, and this, I don't remember but everybody else sort of projected onto it that it would be a cluster manager. So it was very limited in its abilities to actually be an effective cluster manager. And what it did was actually kind of clever. It was more or less just this controller endpoint that would let you submit systemd units, because CoreOS is all about systemd, and then it would more or less SSH to the machines and run the systemd units, and then monitor them as well. Very simple, but there are a lot of things that it was missing that they could have. I guess they just kind of gave up when they were like, "Oh, we'll just use Kubernetes." In theory, I think they say they use Fleet to like bootstrap Kubernetes or something like that, which I think is silly. But when we saw, after we used Fleet and it basically killed everything for no reason because it was demoware, we're like, well, it's basically just doing this with SSH. Let's just do this with SSH. So... yeah, I wish I made some slides because that was really cool. We have a bunch of tools around SSH too that make parallel SSH stuff really easy. Sometimes what we do, because it's a lot faster, is you can just like pipe images to a machine, like Docker export, pipe to Docker import, or I think it's save and load. But and that's a very fast way to, you don't have to go through going to a registry and go to a thing and then you could store your artifacts somewhere else. If people were complaining about the whole registry middleman thing, like there's a way around it.
Just curious, because you didn't mention it, what your thoughts were about Rancher.
I like Rancher. I mean, I like CoreOS. Same idea, right? An operating. If you run Docker Engine, depending on how you're handling things like logging and stuff, it doesn't really matter how much the underlying operating system is. To me, the most important thing is, does it support cloud config, because that is how I do all configuration management now. And so it supports cloud config, and so we started using it. And I like it. They did something that I wish Docker did, which was give you a separation between like system and agent containers set in a separate namespace effectively. It's nice, but there's definitely because they're starting from scratch, we would always run into like little things. It's like, oh, we can't pull from a private registry easily without doing a bunch of workarounds. Little things. There's a lot of potential, though I feel like it was slower than CoreOS, because I mean that was the great thing about the whole systemd idea is basically, if you've read anything about it, it's they're making boot time a lot faster because of a lot of things, not just like socket activation, but sort of lazily evaluating dependencies and stuff like that. So we were using Rancher for a while, but I think we went back to CoreOS because it's just faster to boot, which is really important to me because we not just like production is like, oh, you only boot that once or whatever, like every now and then, but constantly making like sandboxes and stuff that are development sandboxes or development stuff. And so all like boot time and all that is really important to me to have really fast. So I like Rancher. Oh, you said Rancher, huh? But did you mean Rancher OS or Rancher? Because for some reason, I jumped to Rancher OS. Rancher is a totally different thing. Rancher and a lot of things like it, to me, okay, separate from Rancher OS, is sort of like a cluster manager, but like a cluster admin. It's not what I want, I guess. For a lot of people, it's going to be really effective, and it solves a problem for a lot of people, but it's not exactly what I want, so I don't use it. Those guys are smart, though. I like them.
Anyone else?
Would you mind if I ask a question that has nothing to do with cluster management?
I would love that.
Is there a nice way to connect a Docker instance, like the log, to Elasticsearch without having to modify the Docker image or the image that you're running? Is there, yeah.
So that software that I said was terrible, Logspout, is something that I wrote that it was before there were log drivers, but people still use it because it's a lot easier. You don't have to change, you don't have to configure anything. You just run Logspout, and it will attach to all your containers and send your logs to wherever you want, because I believe that you should not be writing logs to disk. You should just be routing them to a central log aggregator, or something that ends up in like Elasticsearch or something like that. And I believe we have, trying to keep things simple, we have a couple backends supported, including syslog, and I think that's maybe what most people use to go to Logstash to Elasticsearch. Does that kind of satisfy what you're looking for? Or do you want to like go?
Terrible though. Is there something better?
It's
You said log drivers. That's I don't know. I guess I
Oh yeah, Docker daemon has log drivers, which is kind of annoying because if you use log drivers, it doesn't store any logs, so you lose any ability to go on the machine and see any history or whatever. It just directly goes to wherever you send it. And the other problem that I have is that the reason why it's terrible is just because I haven't people are, I think, maintaining it, and it's very popular, and people are using it in production everywhere, but I'm not very active. So I think maybe the people in the community are kind of taking care of it, but maybe not. But I know that there's a lot that I want out of it I don't have time to do. One of which is to make it make it also run a syslog server endpoint, because one big problem people have is our multi-line errors, which is very annoying in logging in general. And if you use any kind of line-based system, you're sort of like, you're going to get all these entries on the other end. It just makes it really terrible to deal with exceptions and stuff like this. And as far as I know, the only way around that is to have the application that produces those errors actually send to syslog, because syslog is a UDP packet-oriented thing, so it'll put the entire message in one packet, and so that's treated as one message. And so to satisfy that model, I wanted Logspout to have a syslog server so that all your containers can just send logs to it directly, and then route them wherever. But yeah, I think Logspout is still, even though I say it's terrible, I think it's maybe the the best thing out there, or log drivers, which is really simple. You just have to tell your daemon, Docker daemon, what endpoint you want to send them to. But again, it's also line-based, so.
Anyone else?
You said something about maybe showing us some cool stuff that no one else had seen yet. I would want to see that.
Does anybody else want to see that? It's actually something really cool made with Docker.
Sure.
Okay. Does this still work? Okay, cool. Actually, too, may be easy if I can connect to the Wi-Fi. Is that Docker at event? Oh boy. Was it? It's guest, right? Is that rotated? It might actually just connect. Oh, I see. It's going to do a captive portal. Guest register. Uh-oh. Okay. Because I do need internet. Okay, username is what? Password? It's kind of like pair programming, but as a big group. It worked. Okay. Okay, I'm gonna put it up there. Although maybe this is best. Let's see. Now I need to. Nope. I'm gonna cheat and play a video and talk over it. I lied. Some people have seen this, but not everybody. So I do a lot of stuff with SSH, and so SSH I think is a really cool protocol. It's actually kind of ahead of its time. It's a layered protocol, and it was one of the only protocols that actually was a good generic multiplexing protocol. Now a lot of people use HTTP2 for that. We made a service called command.io, and right now you can only use it over SSH. You log in with your GitHub username, and it will use your key that you've put on GitHub probably. If not, you have to put your key up there. And what command.io is a platform for running commands that you make or install. And so you can basically do anything that can run in a Docker container, because it's basically just running a Docker container. But it's really cool because if you've noticed, you don't need Docker. You need Docker to create the container, but that won't always be the case. And so this is really cool just for, doing commands as a service. You want to take your favorite utilities and use them from anywhere. Maybe, what am I getting? JQ. If you use JQ, you could use it from anywhere. You don't need to install it. You can just use it anywhere you have SSH, and then pipe stuff in and get your JQ out. There are some other, let's see. So this is showing you how you can just kind of add right now. You just point it to a Docker Hub URL, add this JQ, and then you can run JQ. Oh yeah, a lot of people make that comparison, and I have a lot of yeah, and I'm calling tongue-in-cheek commands as a service. And there are differences. It's very similar, but the differences are obviously one is the interface. It's actually a lot easier to access stuff over SSH, but it also is a different class of problems, right? You're usually putting stuff like, I don't know, a little microservice or something like that on Lambda. Whereas this is more kind of administrative shell tools and stuff like that. But the cool thing, and this is definitely a better screen than this screen. Another use case that a friend of mine showed me pretty immediately was certain programs that you install, like LaTeX, are a pain to build. In fact, some of the packages, LaTeX is broken, and then once you install it, it takes up about 1 gig of disk space. And so he usually installs it or tries to install it and then deletes it when he's not using it. And now he never has to do that again. He can just use it as a service. And the interesting thing was that this showed one of the interesting constraints of Command IO, which is it's a stateless service, as you'd probably imagine. So you can't really, like, if it writes a file, it's not going to be there the next time you run it. And also, so it doesn't really make sense to do things that sort of expect things on your file system, right? It's like looking at your local file system. It can't read your local file system. So let's see what we ended up. Well, here's it in action. Here he had a resume that was in LaTeX, and he had a PDF in his repository, and then I just used it to generate the PDF. And it looks just like the one that he had, so it works. But I guess the interesting thing was that we basically wrap it, right? This is the definition of the command. Pretty simple. So if you can't read it, we'll just let you pipe stuff in. The problem is PDF. The problem is LaTeX works on files, not standard in, standard out. So this is a little wrapper that makes it work. But some of the other interesting, so where it starts to get very interesting is sharing access to these commands. So if I made this thing and I basically shared it with his username, and so now he can run it with he shared something with me, I shared it with him, but he made a program called demo and shared it with me. So here I am running it. And it turns out to be a Rickroll shell script. But there's no audio, so it's not a true Rickroll, I guess. The other thing is being able to modify the configuration, which is mostly your environment for your sort of 12-factor Heroku. And this is really helpful for configuring your commands. It's basically the only state that you can manipulate other than the image itself. And this is kind of good for like secrets and stuff. But if you combine those two things of putting in secrets to like credentials to a command and being able to share it, you can start creating basically scripts that you can share with your organization where you don't need to share the credentials and they can all just use them without installing it. So if you have a deployment script or anything like that, any kind of team-based, whatever kind of workflow automation that you might do from the command line, you can put it on Command IO. This was me showing it deploying something. Oh, do you guys use Terraform? I love Terraform. Yeah. So here's one where we made a Terraform command with all the credentials built in for it. And Terraform has state that it needs to manage, but it has enough state to be able to put that into S3. And so sharing this, basically anybody can run Terraform. And in this case, I'm actually tarring the whole directory. So, it's kind of multiplexing files over standard in. And so it just takes them and then has them locally and can run Terraform. And so this way you can sort of turn, your Terraform repository into something that anybody can run. without any of the credentials and stuff. So that's kind of helpful. Oh, here's something else. Git push is pretty cool, like deploying with Heroku and all. It's a pretty cool way to actually do a lot of stuff. Maybe you don't want to deploy, maybe you want to run some tests, or maybe you want to, I used to have some good use cases. So some of them were stupid, like, oh, I want to deploy to App Engine with git push because they don't support that. Oh, well, I could, I've implemented various systems to let you do git push or handle git push, and this is by far my favorite. So here is basically the same thing, but it works over git push. And so I did something interesting where the branch that you push to is the command that it's going to use. So if I push to show, it shows you. If you push to destroy, it's going to destroy. And of course, if you were to do plan or apply, it would show you that output. That's pretty cool, right? You could basically make anything handle git push, any of the files that are sent over git push, which is pretty cool. I'm surprised there's more stuff here. Oh, here's the source. I guess I also made one that would do a Docker build and push it. So maybe your team, they don't even want to install Docker, but they need to be able to build and push it, some update or whatever. Well, they could do this. They could get pushed to this command remote, and it would do the build and push there. So you use it for CI stuff, because a lot of CI systems, one of the things I wanted to talk about with cluster managers, a cluster manager itself is an amazing building block, because it turns out PaaS is not the only thin thing that can live on top of it. CI is another great example where the majority of what it's doing is what a cluster manager does. And there are a bunch of other things that you can think of in this way. For example, distributed cron, task queues, any of the, we have all these kind of old school like task queue type stuff. Usually they're a big part of what they're doing is figuring out where to run it and actually running it. And so those things become a lot simpler if you just have them built on top of a cluster manager. But I brought that up because sometimes we use this instead of a CI because it's just faster. Most of the CI stuff that we have has too much going on, or like Travis and Circle CI are great, but they're just not very optimized to run something quickly. So sometimes we'll just make this have the git push event trigger this. One thing that this doesn't have immediately, though, is an HTTP endpoint. So you can run this stuff with curl. You could run a command. You could curl command.io in your command name, and it would output all the output, stream the output to you, and run it over HTTP, which is pretty cool if you don't have SSH. But that also means that you could run it from anything that can make an HTTP request, including Lambda or CI or whatever. Basically, there is no way to run stuff on the shell as a service. There was no equivalent of Lambda for the shell, and now there is. We use it for deployments and a bunch of other weird stuff. And actually, if you guys want, it's not public yet, so if anybody's interested in playing with it, let me know. That's all I wanted to show, actually. Just another, we're starting to get back into software as a service stuff. I built a tool a long time ago called Local Tunnel. Have any of you used ngrok? Ngrok's pretty cool, right? Useful utility for various reasons. Made by a friend of mine, but it's basically copying Local Tunnel. But it's because I couldn't maintain Local Tunnel at the time because I didn't have enough infrastructure automation, which is why I got into all of this stuff. And now I have the infrastructure automation down. I feel like kind of a pro, at least in my sort of world of it. And so now we're building a lot of really cool services like this. I should stop. Thank you. Thank you for humoring my whatever this was.